Have you ever thought about how the universe behaves at its smallest scale? Welcome to the enigmatic realm of quantum physics, a fascinating domain where the conventional laws of physics seem to take a back seat. It's a world where particles can be in two places at once, where they can spin in opposite directions simultaneously, and where observing them can actually change their state. Yes, you heard that right. This is the quantum world, and it's nothing less than a cosmic riddle. Quantum physics, in essence, is the study of the universe's tiniest constituents. We're talking about particles so minuscule that they make atoms look gigantic in comparison. These quantum particles, such as electrons and photons, are the building blocks of everything around us. And yet, they don't play by the rules we're familiar with. In the world as we know it, a ball can't be in two places at the same time, but in the quantum realm, a particle can be. It can exist in a state of superposition, where it's in multiple places simultaneously until observed. Sounds strange, doesn't it? But that's the beauty of quantum physics. It challenges our intuition and forces us to question what we perceive as reality. But quantum physics isn't just about strange phenomena, it's also about understanding the fundamental nature of the universe. It's about peeling back the layers of reality to reveal the underlying quantum fabric that dictates how everything behaves. And as you delve deeper into this peculiar world, you'll encounter more baffling concepts. Quantum entanglement, where particles become interconnected and instantaneously affect each other, regardless of the distance, and the uncertainty principle, which states that we can never precisely know both the position and momentum of a particle at the same time, are just the tip of the quantum iceberg. So, quantum physics deals with the microscopic world, where things behave quite differently from what we're used to. It's a world filled with mystery and intrigue, where the rules of the game are constantly changing. But remember, as perplexing as it may be, quantum physics is not just about the oddities, it's also about understanding the fundamental building blocks of our universe. Imagine if you could be in two places at the same time. Sounds impossible, right? Well, not in the quantum world. Welcome to a reality where the ordinary rules of existence are suspended, and paradoxes run rampant. This is the realm of quantum superposition and entanglement. Let's start with quantum superposition. Picture a spinning coin. While it's in the air, it's neither heads nor tails, but both at once. Similarly, in the quantum world, a particle, say an electron, can exist in multiple states simultaneously. It could be spinning upwards and downwards all at the same time. Only when we observe or measure does the electron choose a definite state. Until then, it's a blur of probabilities, a superposition of all possible outcomes. Now here's where it gets even stranger. Quantum entanglement. Two particles can become entangled in such a way that the state of one instantly influences the state of the other, no matter how far apart they are. Think of it like this. If you had two entangled dice, and you roll one here on Earth and it comes up a 6, the other one on the moon would also come up a 6 instantly. It's as if the two particles are communicating faster than the speed of light, something that Einstein famously called spooky action at a distance. So you see, in the quantum world, the impossible becomes possible. Particles can be in two places at once, thanks to superposition. They can also communicate instantaneously across vast distances, courtesy of entanglement. But these aren't just theoretical musings. Quantum superposition and entanglement are real phenomena, confirmed by countless experiments. They are the foundation of quantum computing and quantum cryptography, technologies that could revolutionize our world in unimaginable ways. So buckle up. We're just getting started on this quantum journey. There's so much more to explore, so many more paradoxes to unravel. In the quantum realm, being in two places at once or communicating instantaneously across vast distances isn't science fiction, it's reality. Do you think you can measure the speed and position of a moving car accurately? In the quantum world, that's impossible. Welcome to the realm of the uncertainty principle, a cornerstone of quantum physics that challenges our everyday understanding of the world. This principle, first introduced by Werner Heisenberg in the early 20th century, asserts that you cannot simultaneously know the exact position and momentum of a particle. This might sound absurd, but it's a fundamental truth in the quantum world. To understand this, picture a tiny particle, like an electron. In the macro world, where classical physics reigns, we could theoretically measure both its position and momentum precisely. But in the quantum world, the rules change. The more accurately you try to measure the position of the electron, the less accurately you can know its momentum, and vice versa. It's not due to any technical limitations or measurement errors. It's an inherent feature of quantum particles. This strange phenomenon is due to the wave-particle duality of quantum objects. When we measure a particle's position, we're interacting with it as though it were a particle. But when we measure its momentum, we're dealing with its wave nature. The two measurements are incompatible because a particle and a wave are different aspects of the same entity. The uncertainty principle is not about our lack of knowledge or our inability to perform precise measurements. Rather, it's about the very nature of quantum reality. It tells us that the quantum world is inherently fuzzy and indeterminate, a stark contrast to the predictability and determinism of classical physics. This principle has profound implications for our understanding of the universe. It tells us that at its most fundamental level, the universe is a place of probabilities and uncertainties, where things are not as they seem. The Heisenberg uncertainty principle reminds us that in the quantum realm, precise knowledge comes with inherent limitations. You might think all this quantum weirdness has no bearing on your daily life, but you'd be surprised. Let's start with the device you're probably holding in your hand right now, or maybe it's tucked safely in your pocket. Yes, your smartphone. Beneath its sleek exterior lies a world ruled by quantum physics. The transistors that power your phone's processor, the flash memory that stores your photos and apps, even the touchscreen you swipe and tap, all owe their existence to our understanding of quantum behavior. And it's not just your phone. Your computer's hard drive, it reads data using the quantum effect known as tunneling. The precise timekeeping of GPS satellites, they rely on atomic clocks, which use the quantum properties of atoms to measure time with incredible accuracy. Even the sunlight that powers solar panels is a manifestation of quantum phenomena. But the quantum world isn't just powering today's technology, it's also shaping the future. Quantum computing, for instance, promises to revolutionize everything from drug discovery to climate modeling by solving problems that are currently beyond our reach. These computers use quantum bits, or qubits, that can exist in multiple states at once, unlike the binary bits of traditional computing. And then there's quantum cryptography. It uses the principles of quantum mechanics to create perfectly secure communication channels. Any attempt to eavesdrop on a quantum message will disturb the particles involved, revealing the intrusion. In a world increasingly concerned with data privacy and security, this could be a game changer. But perhaps most fascinating is how quantum physics might reshape our understanding of the universe itself. Some theories suggest that the strange behavior of quantum particles could be evidence of parallel universes. Imagine countless realities existing side by side, each with its own version of you. Quantum physics isn't just about tiny particles. It has profound implications for how we live and interact with technology. So next time you send a text or check your email, remember, you're not just using a device, you're dipping your toes into the quantum realm. So, where is all this quantum weirdness leading us? This question, as enigmatic as the subject itself, carries us towards the horizon of the unknown. The future of quantum physics, swirling with potential and possibilities, is a captivating vista of scientific discovery. To begin, let's consider technology. Quantum physics is the cornerstone of some of the most intriguing advancements we see today. Quantum computing, for instance, promises to revolutionize the way we process information. Traditional computers, as remarkable as they are, pale in comparison to the potential processing power of quantum counterparts. Each quantum bit, or qubit, can exist in multiple states at once, opening doors to computations that are exponentially faster and more complex than anything we've seen before. Beyond computing, the realm of quantum communication beckons. Imagine a world where information is transferred instantaneously, with absolute security. This is the promise of quantum teleportation and quantum cryptography. While we're still in the early stages, the strides we're making are nothing short of extraordinary. But the influence of quantum physics extends beyond the confines of our laptops and telecommunication devices. It could redefine our understanding of the universe. Quantum gravity, a theory still in its infancy, attempts to reconcile quantum mechanics with Einstein's theory of general relativity. If successful, it could provide a unified theory of everything, shedding light on the darkest mysteries of the cosmos. As we venture deeper into the quantum realm, we're bound to face challenges. The quantum world is notoriously elusive, defying our conventional understanding of reality. But every challenge is an opportunity for innovation, a chance to reshape our perspectives and push the boundaries of human knowledge. So, here we stand, on the precipice of the future, gazing into the quantum abyss, filled with curiosity and hope. As we continue to probe the quantum world, who knows what fascinating surprises await us? The future of quantum physics holds limitless possibilities.